All right. Monday time, day 41. Let's get it. Okay, so stream is good. Day 41. Let's get it. First, completely painted row or column. You are given a zero indexed integer array, array and an m by n integer matrix mat. Array and mat both contain all the integers in the range 1 to m times n. Go through each index I in array starting from index 0 and paint the cell in mat containing the integer array of I. Return the smallest index I at which either a row or a column will be completely painted in mat. Return the smallest index I at which either a row or a column will be completely painted in mat. Oh, ho, ho, ho. Bow, 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 wow, wow, wow. Okay, so this seems a tricky question. Because m and n can be a large number, right? But let's dry run first. Let's dry run. Okay, so we have here. So this solution is quite okay. So we have an array and mat, right? So we paint 1 first, then we paint 3, then we paint 4. So at this index, which is 2, right, an entire row is painted. So we return 2. Is it an or yeah? Let's take this example. The input array is this, right? Now at 2 we paint 2, at 8 we paint 8, at 7 we paint 7, at 4 we paint 4. Now at this index, which is 0, 1, 2, 3, an entire column is painted, so we return 3. Now since m and n can be pretty large, right? Okay. I mean, it seems easy. So, a simplest way to do this is we know that there are m rows and there are n columns. So we create 2 arrays of size m and n. Now, this will be, let's call it painted p count or painted painted row count, and this is painted column count. So these two will tell me that how many numbers have been painted in this ith row or jth column. Now when that number reaches n, or right, okay, so in row, when that number reaches n, then I know I need to break from that point, right? And similarly for here, when that number reaches m, I need to break there. Easy, right? Let's do that. So int m equals mat dot length, int n equals mat 0 dot length, right? p row int p row count new int m, number of painted tiles in ith row. Similarly for each column we need to do, which is n, right? Then for int k in array, oh, I need to find that number as well. Okay, so finding is a bit tricky now. Finding, okay, finding number is tricky. Now searching, if I search for each number, it'll take a long time, right? Is there a way to fast track that search? Okay, how do I find 2 in here? I can look through each one of them, right? Or I can hash, right? Hashing is a technique here, right? But how will I hash? Like, how to hash this? It is a bit tricky. Now, see, I have to traverse the matrix at least once, right? So can I derive something after traversing at least once, right? What can be done here? I mean, I can simply store the pair of row and column. That would be perfect, right? I mean, I'm taking too long. I mean, too much space here, but fuck it. We call it cache, new int. M times n plus 1. And this will be 2. Store row and col for each number. For int I equals 0, I is less than m, I is I plus plus. Cache of mat of I j equals new int. Right. Then for k in array, p row ct of cache of k 0 plus plus c row ct of cache. Okay, I have to return the index. Okay, what happened here? So column. Okay, so this was actually call count, p call count. Now p row painted row count. There are m rows, right? Right? And there are n columns, correct? Then for each number in that array, I am getting that number's row, which is I, and that number's column, which is j, and then I'm increasing each of them, right? Because that is painted. Then if p row count oh shit, man, fuck. We don't need to do that, bro. Let's see if this works. Okay, it works pretty good. So the time complexity of this is order of m by n, right? So order of n, if we look at this, yeah, order of m by n. All right, good. Let's do a neat code question. Yeah. Now for neat code, valid Sudoku was done. Longest consecutive sequence. Given an unsorted array of integers nums, return the length of the longest consecutive elements sequence. You must write an algorithm that runs in order of n time. So we need to use hash here, like a hash set From there we can use okay, let's see. Now for example, if the input is this, then we create a hash set, right? We see that we found 100 here, so we put 100 in a hash set. Then we found a 4, we put 4 in a hash set. Okay, before putting 4, we also test if 4 if 4 minus 1 is present in the hash set, right? We need to actually go both ways actually, right? Yeah. Yes. Yeah. Okay. What if we use a hash map instead of hash set? We see that 100 is here, so the longest sequence with 100 is 1 up until now. Then we encounter 4. The longest sequence with 4 is 1. Then we encounter a 200. The longest sequence here is 1, right? Then we encounter a 1. We see that neither 0 or 2 is present in the hash map. Then we say 1, right? Then we encounter 3 here. Now 3 plus 1, 4 is present, right? 3 plus 1, 4 is present here. So I'll put the value of 3 as 2, right? Then I encounter 2 here. Now I see 2 plus 1, 3 is also present, and 2 minus 1, 1 is also present, right? So I need to add all of them up. 2 plus 1 plus 1, which is 4. So this kind of shit needs to be done. Now there's a possibility that if 5 comes up, right, and this is not updated, do I need to update all of the sequence, all of the chain numbers? Is that the trick here? There must be some easier way to understand this question. Let's take this example. Yeah, I think I need to go both ways actually. Okay. Okay. Hash map Java. Okay, if I simply do like, okay, let me undo something. Oops. Now I encounter a 1 here. The longest sequence is a 1, right? Then I encounter a 3. I see that 3 plus 1 is present. So I update the count by 1 here. Do I do that? And then I also put the value of 3 as 2. Then I encounter a 2 here. I update the value of 2 plus 3, 2 plus 1, 3 by 1, right? And 2 minus 1 by 1. Something like that. Basically what we need to do is, when I encounter a 2, I'll replace this value by 2, not add 1, just replace the value 2 here. Now when I encounter 2, I see 1 is also there and 3 is also there. So 2 plus 1 plus 1, 4, right? This value is 4, this value is 4, this value is 4, and ripple effect, this value is also 4. That's what we need to do. And we need to keep the track of max. That will what happen now. If contains, is it a contains? No. Contains key. If cache dot contains key n minus 1, chain length equals if it contains n minus 1, then chain length plus equals cache dot get n minus 1. If it contains n plus 1, dot get n plus 1, right? Now then we put cache dot put n chain length, and while cache dot contains temp minus 1, cache dot put temp minus 1 chain length temp minus minus, and we do this shit for the next one. Plus plus plus, and we need to keep track of max chain length. Int max len equals 0. At the end we can simply max len equals math.max Now this might be time limit exceeded. I'm not sure. Oh shit. Bro, my Java is shit. My Java is shit. My Java syntax is utterly shit. Oh shit. He's not stuck anymore. He's not stuck anymore. Let's go. Time limit exceeded, man. Yeah, wrong answer. Okay, how this is wrong? 1201. Ah, shit. Fucking hell. Do I keep track of visited as well? If cache dot contains key n, then continue. Yeah, time limit exceeded. So let's look at my past solutions or submissions here. So I did this in Java. What was the thing here? Hash set arrays.stream. All of the numbers are put into a hash set, then max line equals 1 for int n in nums. If set dot contains n minus 1, int count equals 1, while set dot contains n plus 1, count plus plus, set dot remove n. What the fuck? If set doesn't contain n minus 1, then we move up. Yeah, this is clever. This is pretty clever. Very clever solution. But is there any faster solution than this? Let's see this. What is the same shit? In C++. Same shit. Yeah, same shit. Okay. Let's do the same shit again. So we simply need to avoid traveling in both directions. Just go in one direction. When you make sure that n minus 1 doesn't exist, so only thing that exists is n plus 1, right? Hash set integer hash. What was that fucking what? Arrays.stream nums, this I understand. Then dot boxed means converting this int to integer. Then to list, right? Collectors dot dot collect, collectors dot to collection, hash set new. Crazy. That's why I hate Java, man. I could have just, for simplicity's sake, let's do this. For int nums cache dot put n. Add. Now for int in nums, if cache dot contains n minus 1, if it doesn't contain n minus 1, then int max int alien chain equals 0 while cache dot contains n plus 1 cache dot remove n chain plus plus is not stuck anymore. Okay. Okay, this works. Perfect. So we did 2 questions today. Monday bang bang. Alright, so I'll be back tomorrow with another set of questions. Until then, GG's.